In this presentation, you will learn about BTG's pyrolysis process. The base of this technology was invented at the University of Twente in the early 90s and further developed by BTG. A pilot plant has been tested from 1997 and has proven to be reliable at this scale. Now, the first commercial production unit has been delivered. This film will show you the background, the principles and the possibilities of this technology. Bioenergy technologies use renewable biomass resources to produce, for example, electricity, heat, automotive fuels and chemicals. The current EU target is to double the share of renewable energy in primary energy production, from 6% in 1997 to 12% in 2010. BTG Biomass Technology Group has, over the last 25 years, specialized in the process of conversion of biomass into biofuels and bioenergy. BTG's two business units, consultancy and R&D, work in synergy. This unique combination is the base for highly innovative and commercially feasible activities. BTG wants to contribute to a sustainable energy society. To achieve this, BTG works on the development of technologies that helps biomass to replace fossil fuels. Coal, oil and natural gas are non-renewable fossil fuels. These are produced in naturally occurring processes in which organic material is converted over a period of millions of years. BTG strives to dramatically reduce the conversion time of this process. For example, biomass carbonization as a technology to substitute coal, biomass gasification to substitute natural gas, and biomass pyrolysis to substitute crude oil. The rapid conversion of biomass into biofuels raises the energy density of the biomass. BTG has developed a patented biomass pyrolysis process. The base for this technology was an invention from the University of Twente in the early 90s. The fast pyrolysis process is further developed and scaled up by BTG, who is now a prime supplier of the technology. Fast pyrolysis transforms difficult to handle biomass into a clean and uniform liquid, pyrolysis oil. A wide variety of feedstock materials can be processed by fast pyrolysis. Examples are wood, straw, rice husk, bagasse, sludge, palm residues and many more. The particles must be reduced to a size below 10 mm. The moisture content should be below 10 weight%. BTG's fast pyrolysis technology is based on the rotating cone reactor. Biomass particles at room temperature and hot sand particles are introduced near the bottom of the cone. There, the solids are mixed and transported upward by the rotating action of the cone. In the process, up to 75 weight% pyrolysis oil and only 15 weight% char and gas are produced as primary products. Since no inert carrier gas is used, the pyrolysis products are undiluted. This undiluted small vapor flow results in downstream equipment of minimum size. In only a few seconds, the biomass is transformed into pyrolysis oil. Charcoal and sand are recycled to a combustor, where charcoal is burned to reheat the sand. The permanent gases can be utilized in a gas engine to generate electricity or simply be flared off. In principle, no external utilities are required. BTG has a 1 megawatt thermic pilot plant available at the BTG laboratory. This pilot plant has been tested for many types of biomass and residues. The pilot plant has produced about 100 tons of pyrolysis oil. Pyrolysis oil can be used in a large number of applications, which can be divided into 4 main groups: heat, power, transport fuels, and chemicals. Pyrolysis oil combustion in a boiler or furnace for heat is shown to be the most simple application. Co-combustion of pyrolysis oil in an industrial power plant has been successfully demonstrated. Diesel engines and gas turbines for power production have been tested on pyrolysis oil. Some development is still required, and commercially available engines or gas turbines will be adapted within a few years. Also, transport fuels can be derived from pyrolysis oil, either by direct upgrading or by gasification combined with gas-to-liquid synthesis. Last but not least, potentially high-value chemicals can be extracted from pyrolysis oil, like adhesives for wood, preservatives, flavouring of food and more. These applications need further development. Recently, BTG has delivered a 10 megawatt thermic pyrolysis production plant to Malaysia. Malaysia can be seen as one of the so-called green OPEC countries. These are countries that have the potential to develop into large suppliers of biofuels. Other green OPEC countries are, for example, Indonesia, Brazil, Canada, and northwest Russia. In Malaysia, various biomass residues can be found, residues which are otherwise left in the field and would release large amounts of methane, a harmful greenhouse gas. In other cases, the residues are burnt in an inefficient manner to get rid of them. These residues are suitable for feedstock for the fast pyrolysis process. The organic part is used as energy carrier. Minerals can be returned to the soil as fertilizer. A client of BTG in Malaysia, belonging to the top companies in Southeast Asia, worked together with BTG on the development of this commercial production unit for the pyrolysis of palm oil residues. This company is well respected for its integrity and corporate governance, and member of the Round Table on Sustainable Palm Oil. The 10 megawatt thermic production plant was built in the Netherlands and disassembled and transported to Malaysia. The plant arrived in Malaysia in April 2005 and is operational since July 2005. As explained, the feedstock for fast pyrolysis needs to be reduced in size and the moisture content should be below 10 weight%. The palm residues are reduced in size by a shredder and dried by a dryer. This pre-treatment is an integral part of the plant. Waste heat is available from the pyrolysis process for drying. The particles are conveyed through lock hoppers, separating the reactor from the feeding system. The palm residue particles and hot sands are introduced near the bottom of the cone reactor. The solids are mixed and transported upward by the rotating action of the cone. In only a few seconds, the biomass is transformed to pyrolysis oil. Charcoal and sand are recycled to a combustor, where charcoal is burned to reheat the sand. The permanent gases can be utilised in a gas engine to generate electricity, for example. The pyrolysis oil is stored in large storage tanks. The first commercial production unit has been put in operation now. Many more will follow. Pyrolysis oil or other biofuels will replace fossil fuels on the longer term. In BTG's vision of the future, the so-called green OPEC countries will develop into large suppliers of biofuels, like pyrolysis oil. Pyrolysis oil, produced from various residues in forests, at plantations or at agricultural sites, will be transported to nearby harbours. The pyrolysis oil can be transported overseas in bulk tankers to large industrial and utility sites elsewhere in the world. This allows the implementation in the existing infrastructure for liquid biofuel utilisation. Further distribution to small-scale applications for standalone electricity, district heating or chemicals production is also possible. In this way, fast pyrolysis oil can be traded as a green commodity. It will partly replace fossil fuels everywhere in the world and contribute significantly to building a sustainable society. We showed you the background, the principles and the possibilities of BTG's pyrolysis process, a technology developed by BTG, which is now commercially being applied. BTG continuously works on the development of new technologies for the production of heat, power, transportation fuels and chemicals from biomass. Working closely with industrial partners, these technologies are scaled up to commercial scale production units. We warmly invite you to work together with BTG to further develop these technologies and work towards a more sustainable society. BTG Biomass Technology Group, your partner in bioenergy.